All right, folks. Hello there, and welcome everybody out there. You may have heard me cough a minute ago. I thought I had the mixer turned down, but there's more than one. Anyway, hey, thanks for joining us tonight. You're watching Amateur Radio Roundtable. It's a show about ham radio, amateur radio, shortwave, and a lot of things associated with it in electronics. We're glad to have you tonight. And especially if you're out there listening on WBCQ on 7490, we'd love to hear from you. Send us an email and let us know where you are in the world and where you're hearing the station from tonight. You know, what kind of signal report you can give the station. And just send that to Tom at W5KUB.com, Tom at W5KUB.com, and we will be glad to hear from you, and we'll reply back to you there. Okay, would like for you to join our Facebook group. It's just called it's actually called Amateur Radio Roundtable, but that's a pretty long name to type in. If you just search for W5KUB, it'll take you there, and we'll approve your membership into the club there. We've got about 15,000 people in that ham radio group, and a lot of activity in that group, and a lot of neat things going on. So please join us there. Hey, hit the subscribe button on YouTube, and hit the like button and hit the subscribe button, all those things that helps us to advertise the show when people are, kind of searching YouTube for information about radio and electronics and things like that. Hey, tonight, Hambot's going to be with us tonight. We're going to give away a Heil handbook, ham radio handbook, and this one has been autographed by Bob. You guys know Bob is a silent key, and Bob is not with us anymore, but Bob has been a big supporter of us and our webcast for 20 years. In fact, he gave us our first pro microphones where we were starting out with little $3 computer microphones, and just a quick story, Bob always says those microphones, those pro mics that I've got there, he always tells people that Charlie Daniels and Carrie Underwood use that mic. And I say, Bob, when you tell that story, tell him also Tom Medlin uses that mic, put our name in here. But anyway, we're going to miss Bob, but we're going to send this out. Hambot's going to pick somebody tonight after our first segment, and be glad to send that out to you. We're going to talk tonight a little later about some of the Hamfests coming up, and maybe just some news, and I've got some things I'm interested in. EME, I wonder if anybody out there is working any EME, and I want to talk to them about that. So first, let's just jump over to Glenn and see how Glenn's doing. And Glenn, I thought you were going to be at a club meeting tonight.
I was, and it ended just in time for me to be able to get here.
Yeah. Oh, you made it, huh? So, okay. Well, very good.
Yeah, I made it.
Well, how many people are? Is this the Little Rock Club or Conway?
This is the Conway, Arkansas, Faulkner County Amateur Radio Club.
Okay.
And there was probably about 25 people there.
That's a good group.
And they had dinner, a dinner meeting there at a local barbecue joint. So we had barbecue for dinner. It was pretty good. They had fried okra. I have not had good fried okra in a while.
That'd be good.
So, yeah. Oh, yeah. So we clogged up the arteries with some fried okra.
There we go.
And we topped it off with some fried onion rings. But yeah, and their spicy barbecue sauce is quite good.
Hey, man, I love the onion rings. All right. People in the chat room are saying, turn on my studio lights. The studio lights are on. I was trying to balance my lights tonight, guys, with this new program. I know the colors are off a little bit. I don't need to turn the lights on.
Yeah, you're looking a little blue.
I don't need to turn the lights on. I can click on my camera shot here, guys, and I have 300 different things I can tweak to make the picture look right. And I just don't know which 300 to tweak yet. I've tried, and, oh, man. Anyway, okay. Hey, Brett, come in here real quick. Tell us what you're doing.
Yes. Well, I'm getting ready. I just got back from a trip to the East Coast, and just was delayed in Atlanta by a plane having an engine fire, and all the people having to exit off the middle of the runway. But I
Oh man.
managed to get back okay, and now I'm back at work. I can't put radios on people's roofs to connect them to the internet right now, and so I am building equipment and having all kinds of fun doing that. I'm also getting ready for a Hamfest this coming weekend down in Colorado, which I guess if we're going to be talking about Hamfests, we'll get to later. Um, One of the biggest Hamfests in the Rocky Mountain region is coming up this next weekend, and I'm really excited to go to it because I've got a shopping list.
There you go.
You know, man, you have an exciting life here. I've been on hundreds and hundreds of flights, commercial flights, mostly all international. I've never had an engine catch on fire.
Now, a friend of mine was a seven. Go ahead, Brett.
Oh, well, yeah, they apparently they aborted the takeoff, and the plane was sitting there on the runway for several hours. I was in Denver trying to get to Atlanta, and Southwest started canceling all the flights. So I took a look at what flights were available that might get me there, and I flew to Phoenix. Now, Phoenix is 1,500 miles in the wrong direction.
Yeah.
So why did I do that? Well, it's because Phoenix is Southwest's hub. And I figured, okay, if they've got to get their pilots someplace, if they've got to get their crews someplace once this is all cleared up, the thing they're going to prioritize is the flights out of Phoenix. So I flew there, and sure enough, it was one of only 2 flights that managed to get to Atlanta that night at all.
Wow.
So I played I guess I played the game right, and I was lucky, and I managed to get to Atlanta, where it was a good conference. I had a lot of fun there.
Yeah. I only had one experience with the engine. We were leaving Mexico City, and I think I think they call it a flame out. The engine just went poof and just quit. And the pilot said, no problem. We'll just start it. And we'll try again. And of course, the wind changed. He had to go down to the other end of the runway, but we made it. So, oh man, some people have all the fun.
Friend of mine was a 727 pilot. Actually, he's a ham, W4IET. Was a pilot for Eastern Airlines, and he had a 727 blow up an engine on takeoff at West Palm, in fact, and was able to abort the takeoff. And yeah, that was kind of fun. Evacuated all the passengers out the slides and everything. This was in the 70s.
Well, I think our guest tonight, I don't remember. I think he may also be a pilot. I will ask him in just a minute. Just one last thing. I've got a lot of pilot friends, and my job was basically for 30 years with FedEx and with pilots and stuff. And I found out that there's no such thing as too much fuel unless you're on fire. That's what they tell me. No. And I don't know how some of these planes would, make it from Australia to the U.S., without refueling, but they did it. Okay, hey guys. Okay, let's jump into our segment tonight and introduce our guest we've got here tonight, and we're going to be talking about in-fed antennas, and this is going to be interesting. I first confused it with in-fed half-wave, but let's talk about in-fed. There is a difference, and there may be a interesting difference there we need to talk about. So let's bring Bob in. Bob, how you doing there, man?
Hey, I'm doing just great. I'm looking forward to having a good conversation tonight, and maybe we'll show you something you probably haven't seen before.
All right. Well, listen. Hey, guys out there, this is Bob Brim. Did I pronounce that right? Bob?
Yeah, Bob Brim.
Bob Brim, he's the chief engineer of Palomar Engineering there. And hey, Bob was licensed just a little bit before me. He's the old timer in the group tonight. Bob was licensed in 1963. I didn't get my license till 64. But we got a lot of similarities, Bob. You've got your first class commercial license or your general radio license. I've got that. We kind of did some of the same things there. But Bob does it all, man. He's an auctioneer of ham radio equipment. He's a boating enthusiast. Did I read somewhere you were a pilot?
No, I'm not. I don't get high that way.
Okay, don't get high that way. Okay, well, very good there. Very good, man. All right, well, hey, we're going to talk about, I'm just going to turn it over to you, and let's just jump into this thing, and let's talk about end-fed antennas, because I think I actually already learned something tonight getting ready to have you on the show. So go right ahead.
All right, so I'm going to share, I'm going to do a little PowerPoint here, and I'm going to share the screen if I can find where it is right here. And let's see if we can share that. Okay, I'm sharing. Hopefully you can see that.
It is there.
It is there. Okay, so
Yeah.
tonight we're going to be, I'm just going to take it over, I guess. Tonight we're going to be talking about the sequence of end-fed antennas, and there's all types of end-feds, and I'm going to walk you through some of the different ones and how to use them and what's good about some, and et cetera, et cetera. So without further ado, let's dive into it. But let's see if I can get this thing to, there we go. I'm going to give you, some of you who may not know about Palomar Engineers, it was founded in 1965 by Jack Althouse, K6NY, and he passed away in 2013, and his two kids were CPAs and didn't even know what a diode is or electron. So they had put the entire company, which was a very large company, prior to his death, they had consolidated the entire company into a 10-foot by 10-foot storage area, including all the engineering drawings from day one, which were all written in pencil, because Jack kept changing them over the years and had quite a few products, over 300 different products. And anyway, he passed away, and my wife and I bought the company, and we completely reoriented it towards RFI solutions, and ultimately it's become a big antenna company too. And our objective was real simple, is provide products that make it radio communication more enjoyable and more fun. I had previously run multiple companies, public companies, multi-million-dollar companies as CEO, and I just wanted to get a company that we're going to have fun on. Been doing ham radio for such a long time, it was just nice to buy a company which is kind of like your hobby. And we've had wonderful friends and thousands of customers because of that. Anyway, our product line is antenna systems. We're going to talk about some of those tonight. The end feds. We also do a lot of off-center feds and loops and terminated and all kind of fancy different types of antennas. We make a lot of balance and ununs and feed line chokes, and we pioneered something called a coax noise filter, which I'm going to spend a few minutes on later on, and how it's really useful in your shack. We do general RFI solutions for hams, for households, marine, RV. We do a lot of military communication bands, that type of stuff. And we also sell ferrite core products and rings, snap-ons, slip-ons. We're not going to spend much time on those, but a lot of the things that we do are involved with radio frequency interference. And for those of you who may have remembered Kurt Sturba was Jack Althouse, or vice versa. Jack Althouse was Kurt Sturba. Wrote years and years and years of issues of a weekly or a monthly column for both World Radio Magazine and also for Ham Radio Magazine. And we have taken all those episodes, and there are free downloads on the website. So if you want to remiss back into them, kind of comedy, a little bit of technical, but really fun to read. And we distribute through Ham Radio Outlet. We've got dealers all over the world, et cetera. So let's dive into the end-fed workshop topics, because I think that's where we want to go. And so tonight I'm going to be talking basically a little overview of antenna feed points and what end-fed really means. Talk a little bit about dipoles, off-center feds, ZEPs, those types of things. And then we're going to be talking about the three most popular end-fed antennas. And that's the resonant end-fed half-wave. Very popular now, and we'll talk a little bit about that. But there's also the non-resonant end-fed. Those are called end-fed long wires. And then there's a third one, which we pioneered about a year and a half ago, which has just taken off like crazy. It's called a resonant end-fed off-center fed. And we'll talk about what that means. It's kind of confusing, but we've got some real interesting things that it can do. Talk a little bit about how you set these things up and how you configure them for both local and DX operations, and then how to choose one that meets your needs for bands, power, space, etc. We do a lot of POTA and SOTA antennas, and we also do a lot of contesters. I'm a former RTTY world champion, so I know how to make these antennas sing, whistle, and dance. And then a little bit about feed line chokes. And if you have any questions, we'll spend some time answering whatever you need. All right, put on our thinking caps. And we're going to talk a little bit about antenna feed options. Now, when you think about antenna, a lot of people just think of a simple dipole. And a dipole typically is, it's equal on each side. And depending upon the height of the dipole above ground, the antenna impedance is going to be roughly 25 to about 120 ohms. It's lower when you have lower elevation, and it gets higher when you get a little bit higher. The second type of antenna feed is an off-center fed. In other words, you don't feed it quite at the middle, you feed it a little bit off to the side or a lot off to the side, depending upon what the characteristics are that you want. And if you go all the way to the end, all right, you'll get what they call an end-fed half-wave antenna. And those impedances are roughly 2,000 ohms, 2 to 3,000 ohms. They're very high. The off-center fed's about 200, and the center fed's about 50 to 75 mostly. And so with those three different sizes of impedances, it takes a different type of impedance transformer to make them work correctly. So let's go look into a typical resonant dipole example. And that would be a typical dipole. We're going to use the 40-meter dipole as the example throughout this talk tonight. And typically they're about 33 feet on each side. But if you mount it real low, one of the tricks that you can do, and Buddy Pole does this all the time with their real low mounted antennas, is they don't feed it exactly in the middle electrically. They move it to the side a little bit electrically. It may be physically the same size of antenna elements, but they put a coil in there or they put something else in there to make it so that effectively it's being fed a little bit off to the side so that the impedance is raised. Remember, as you go to the outside all the way to the end, the impedances start to go up. And so that's their trick, and it makes it work very well. And they've had great success with that antenna. And but like all antennas, it does need a choke on the coax for a whole bunch of reasons, which we'll get to in a few slides from now. The typical length of a half-wave dipole is a simple formula. You take 468 and you divide it by the frequency in megahertz, and that gives you the length of typically what it's going to be. And for the purposes of what we're talking about, that's about 64 to 66 feet of wire for a 40-meter typical antenna. Now, if we take that same length of wire, we can do what they call an off-center fed antenna. And here's a picture if you can see it, otherwise I'm just going to describe it. We do our off-center dipoles a lot different than everybody else does. And the reason that we do that is because we get more bands, more frequencies covered with the same amount of wire. So our off-center dipole, for example, has got one side that's roughly 11 feet and the other side is 55 feet. And when you go out with those distances, the impedance is roughly around 200 ohms, but it's about 200 ohms on all bands. All right, so we can work more than one band with this antenna. And in fact, with our setup like it is, basically 17% on one side, 83% on the other side, we can work all bands, 40, 30, 20, 17, 12, 15, 10, and 6 meters with the impedance transformers that we put into the antenna. And by the way, we use a 4-to-1 balun, which is balanced. That's what balance stands for, balanced. And we put a 1-to-1 choke in the same box so that you don't have any problems with coax feed line radiation. Again, we'll talk about radiation in a couple minutes. And in this particular picture, the coax goes into something called a coax noise filter, which then goes into your radio station. And we have different off-center feds for 80 through 6 meters, 40 through 6 meters, or 20 through 6 meters, basically using the same dimensions as an 80-meter dipole, a 40-meter dipole, and a 20-meter dipole, but for the same amount of wire and feeding it off center, we can pick up just virtually all the bands. And because our balunds are so wide band and we make them completely different than most people, we have virtually flat from about 1 megahertz up to about 80 megahertz, and they match really well. I'll give you another slide here, and that is, here's a typical off-center fed dipole SWR graph. And what it is, it's just a typical, the gray lines up and down are the bands. This is 40 meters, 30, 20, 17, etc. And the red line, of course, is the SWR. The SWR 3 is up here, and you can see that most all of the bands are a nice dip, and usually below about 2 to 1 SWR. What that means is you really don't need a tuner if you've got a tuner in your radio, or if it's low enough, you don't even have to hit the tune button. It'll work just fine. So if you're a POTA person or a SOTA, Summits on the Air type thing, and you're working 20 meters or 15 or 10, you don't need a tuner at all. It'll work just fine. On the other hand, if you want to jump over to 15 meters or 17 meters or 12, all of which have been really hot in the last 90 days or so, you can work guys on those bands and not have to do anything except switch your band switch. So it's really, really convenient. And as a bonus, you get 6 meters too. So you get all the bands from 40 to 6. It's a real nice convenience. Okay, and we have thousands of these in use. They're really, really handy antennas. All right, so let's go to end-fed antennas specifically. We talked a little bit about dipoles and how you can feed those in the center or a little bit off-center feds. Now let's jump into end-feds. So there's basically 4 types of end-feds. The old ones that we had back in the 60s, you'll probably remember these. They're called end-fed ZEPs, and very popular, and typically a single band, and we'll show you a picture of that in a second. End-fed half waves, which are the current rage right now among a lot of the hams and stuff, because they don't know any better about the last 2, which are non-resonant end-fed long wires, and also the resonant end-fed off-center fed, and both of which use tricks of the hand to generate frequencies that you wouldn't think are possible from that length of antenna. So let's jump into the end-fed half wave picture, and that's a half wave. So in 40 meters, you'd have a 66 foot piece of wire, and you would feed that with a quarter wavelength of ladder line. It can be ladder line, it can be coax. It doesn't make any difference, but typically it's ladder line. And if you remember your physics, if you have a very high impedance at the end of the half wave, and you put a quarter wave transformer on it, it will be 0 on the other end, all right? Whether it's shorted or not, it will be 0 if it's exactly a quarter wave. And so what that means is that if you go up from the end, the 0 end a little bit, you'll find a point where it's 50 ohms, all right? This is the same principle that the J-pole uses, except the J-pole doesn't have a horizontal half wave. Typically it's vertical, all right? And you're tapping down on a 2 meter or a 6 meter J-pole, for example, you're tapping down to the point where it's 50 ohms. And then you're going to connect your coax there, put a little choke on it, and then feed it to your station. That's a real popular single band antenna. It's, like I say, 66 feet long and about 33 feet of quarter wave, and it needs a feed line choke, of course, and not too much used anymore, but still Great if you need a single band antenna. The next one, which is the rage right now, and we sold this configuration for probably about 3 to 6 months, and that's the end-fed half-wave product. Again, it's a 66-foot piece of wire, and we have in this case, you have to feed it at the end, and that's a very high impedance, remember. So we used a 49-to-1 unun, which converted it up to about not quite 2,500 ohms. And then you plug your coax into the bottom of it, and then on the feed line, you actually put a choke. All right, we find that by putting a choke on there, it actually performed a lot better than not putting one on there at all, which is what most people do these days. It was a satisfactory antenna. A typical configuration looked like the picture in the following page, and that was we hoisted the 49-to-1 as high as we could. We ran the wire out either as a sloper up or down, or horizontal, or it can even be vertical for that matter. And then on the coax, ran down from that, and that's where we put the choke. And we put it down varying amounts depending upon which bands we'd like to emphasize. And then from then, of course, it went right into your radio. And if you have the one that's 66 feet long, you can work about 4 different bands very easily. And I'll click on the next slide here, and that's the picture of the SWR of this particular antenna. And you'll see that there's a very nice dip at 40, down to 1.5 SWR. 20 is just virtually the same. 15, which is the third harmonic of 40, is very nice. And of course, 10 meters is too. And that's about all you get. You don't get the middle, you don't get any of the work bands. And you can work the work bands by using an antenna tuner. The only problem is the balun or the unun itself is going to be sweating. And so you really have to back off on the power because the match is so bad on those bands and that you can easily saturate those 49-to-1s. And I'll just give you a little background here on making ununs and baluns, since we make tens of thousands of those a year now. And when you have a very high impedance unun or a balun, like a 49-to-1, the bandwidth is very small. It's very hard to do one from 1 to 30 megahertz that doesn't require a whole bunch of compensation inside on different parts of the bands because the impedance ratio is so high. On the other hand, if you take a 4-to-1 or a 9-to-1, you can make those virtually flat from 1 megahertz to about 80 megahertz, and you don't have the unun or the balun is not sweating at all because it has a very nice impedance range, all right? Whereas a 49-to-1, if you were to run an SWR graph with a 2,500 ohm resistor on it, you would find it was not flat at all. It'd be very good at the low end, and it would go up around about 15 megahertz. It starts to climb a lot, and by the time you get to 10 meters, it's got a 10-to-1 SWR, and it's only fixed by compensating it. But that's just a clutch. Really, it doesn't really work that well. So this configuration is typical of most 66-foot end-feds. Like I say, a lot of people use the 20 through 10 one, and that allows them to work 20, 15, and 10, and that's about 33 feet. So those are the two most popular ones. One thing I should caution you about is that since these are fed at the end, they are also very, very high voltage at the feed point, all right? And they are somewhat dangerous if you're feeding a lot of power into them, particularly if you're running them from your home station. And in fact, I made a little chart here because people didn't believe this, but even if you're running 20 or 30 watts at the feed point, you've got 271 volts of impedance at the little place you hook your wire to. And if you're up here and you're running 900 watts, 1,000 watts, there's almost 1,600 volts there. And so you got to really be careful of where these are placed, making sure that your animals, your pets don't come in contact with them, or that the outputs are covered, because there's an enormous amount of voltage there that could prove to be fatal under the wrong conditions. So we, for that reason and for a couple more, which we'll expand on in a couple seconds, we discontinued that antenna. It only has 4 bands on it, and at this particular length, and we decided that there are better ways to utilize that length of wire. And one of the ways that we're going to do that is called the non-resonant end-fed long wire, which is our next antenna. The first one we came out with was a 71 footer, and that had a 71 foot piece of wire on it. And subsequent to that, we've had 41 footers, 111 and 155 and a 173, which have been really, really popular. Different lengths, of course, and they cover different bands. And we make them in 100 watts, 500 watts, 1,500 watts, and 5 kW for the hardcore RIDI and the contesters and stuff like that who need very high duty cycles. And the typical setup is very similar to what you have with the end-fed half-wave. All right, you're going to take your matching transformer, which in this case, since it's a long wire, we only use a 9-to-1. Very flat, very easy, matches just about anything, and as long as we pick the right length. So a typical installation would be, about a 20 to 30 foot pole. You hoist the matching transformer to the top with some paracord and a pulley, and then you stretch out your wire. It can be zigzag, it can have 90-degree bends in it, it can go out, it can go up as a sloper, down as a sloper, it can go along the eaves of your house to hide it from homeowners associations. I've had people run them on their fence posts, okay? And I've had the people run the shorter ones from high rises in New York City. And a couple of guys who have, they're on the 30th floor and they run the shorter one, the 30-footer, the 41-footer actually, down their hallway and zigzag it, and they're working into Europe with it, those types of things. All right. But anyway, the 71-footer is pretty unique. It's a little bit longer than the 66-footers we've been talking about, but guess what? You get 80 meters and 60 meters with it too. All right. So you can work all bands 80 through 6. All right. But I'll tell you, here's the trick. All right. Why can it work those bands, which seemingly they're so out of frequency? Here's the trick. When we put these antennas up, we utilize the coax as part of the antenna. All right. Let me repeat that again. The coax radiates all the way down from the matching transformer itself, all the way down to where we put the choke. So in this case, we're going to put the choke down at 42 feet from the matching transformer. So how long is our antenna? It's really 42 feet plus 71 feet. That's 113 feet, and that makes it resonant right above 4 megahertz, all right? But that's irrelevant. It could be any number as long as it's not resonant in the ham bands. And so we utilize the coax, and that's why we like to put the transformer up high, so that the coax radiates, and in fact, you get a vertical component, which is great for DX, all right? And they use the wire part of it for the horizontal component, all right? And you can like I say, you can zigzag it, you can do all kinds of things with the wire, but they both radiate. You don't want to roll up the coax. It's like rolling up half of your dipole. Well, in fact, what does this look like? If you can imagine, this is really an off-center fed antenna, and we're using a 9-to-1 to feed it. One side is 71 feet. It's fed off the center, all right? And it's 42 feet on the other side. And guess what? The impedance on just about all the bands will be somewhere around 400 to 500 ohms, all right? In fact, if we look at the SWR graph on this typical 71-footer, you'll find that there's a very nice dip at 80 meters, one at 40, 30, 20, 17, etc. And virtually all the SWRs on those bands are very close to 2-to-1 or less. But I also get 80 meters, all right? So if I have a 71-foot piece of wire My internal transceiver tuner can tune that, all right? Or if necessary, I don't need one at all, depending upon the band. But here with 71 feet, I get 10 bands, all right? And the trick, of course, is I'm using the coax as part of the antenna. But it's great for DX if I want a vertical takeoff angle. Very nice, very convenient to use. Now, if I expand that wire from 71 feet up to 155 feet, all right, I get this antenna here. We call it the bullet antenna because the impedance transformer looks like a big bullet. And when the Boy Scouts were here and we created this antenna about 12 years ago or so, I had the antenna and they threw it over the tree limb here and it landed on the other side. And one of the kids said, "Looks like a big bullet, Bob." And so we named it the bullet antenna after that. And so it's always been that name. But anyway, here's the 155-foot antenna. And as you can see, it works all bands, 160, 80, 60 meters, 40, 30, all the way down to 6, which is not shown here. And the SWR, if you look at the line here, for virtually all the bands is under 2 to 1. So you can work all bands, 160 to 6, 11 bands. Now the choke is not going to be at 42 feet, it's going to be at 95 feet. So you need a little bit more coax, all right? And you can, pull your impedance transformer up to the top of your tower and then just sway off the coax to the side a little bit and run the rest of it into your shack. We put a transformer at the 95-foot mark, which is a real simple thing, and we'll show you some examples later. And now you've got an antenna that does all 11 bands, all right, in a simple space. And in fact, I've had people ask me, well, what if I go to 270 feet or 300 feet? Can I get more bands? I say, you'll get more gain, but you won't get any more bands because we've given you everything that you need right here. So this is an example of a non-resonant NFED, all right? Now I'm going to introduce you to the last one, which is a resonant NFED, all right? Similar to the resonant NFED half wave, but we're going to put a little trick to it, all right? And the trick is we're going to use some of the characteristics of the NFED half wave we originally talked about, as well as the non-resonant long wire, which we currently were talking about. So let's jump into the next one here, all right? We call it an off-center fed NFED, all right? Remember, the NFED long wire was non-resonant, and it was really a non-resonant off-center fed antenna. So what we're going to do now is change things just a little bit. Instead of making it non-resident, we're going to make it resident, okay? And it's still going to be off-center fed. It's going to have a long piece of wire, and it's going to utilize part of the coax as the antenna. And we make them in 3 different versions, and of course you can make these yourself when we sell all the different parts for you to do that, and a lot of people do. We sell them in what we call the 2006, the bullet 2006, and that's 20 through 6 meters. The wire length is only 25 feet. Real easy to put up on if you're doing a contest up in the park or something like that. And the choke is at the 7-foot mark. The 80-meter version, again, is the wire is about 95 feet long, and the choke is at the 40-foot mark. So what does that mean? A lot of our customers said, I only got a lot that's 40 feet wide and 100 feet long. I can't fit a 135-foot antenna in it for a half-wave 80-meter dipole. What do you got? So we came up with this antenna where you only have 95 feet of wire, so it fits in their lot, and they put the choke at the 40-foot mark and the rest of the on the coax, and then the rest of it goes into their place, and now they have 80 meters in a place that they couldn't put it before, all right? Likewise, the 20-meter one is used by a lot of folks also up in the high rises in New York City, behind in their attics, all different types of places where you normally couldn't put an antenna. So let's look at some of the characteristics of these. And again, the installation is very, very similar to the other 2 antennas, all right? You would but in this case, it's fed with a different impedance transformer. It's fed with a 4 to 1 rather than a 9-to-1, all right, because it's resonant, just like the off-center fed dipole uses a 4-to-1, all right, because we're going to find a spot on this antenna. Okay, remember the original one that we have was 13% and 83% and 17%. This is very, very similar to those percentages, and we're using a 4-to-1, which is even flatter, all right? And at that particular point, again, we have approximately 200 ohms for all the different bands. But now we have a shorter antenna than an end-fed half-wave, significantly shorter, and everybody feeds their end-fed half-wave with coax anyway, so why not use part of the coax as part of the antenna and get a vertical component out of it so that you can work a little bit more DX with it. So these are stealthy. We get all the bands 40 through 6 meters, which the end-feds cannot do because of the limitations of the 49-to-1 transformer. We give you all those bands, and it's a safe antenna. There is no high voltage at the impedance transformer. The other thing I forgot to mention, on the end-fed half waves, since you're voltage feeding it, there's virtually no antenna radiation except for the middle of the antenna, because that's where the current is. All right, there's no current at the feed point of the 49-to-1. On these antennas, both the non-resident and the resident ones, the current is right where the unknown is, right where the impedance transformer is. And so you have a high radiation right there going to a low radiation at the end of the antenna, just kind of like a vertical does, right?
Yeah.
And it's very, very useful to do that. On the other hand, the coax radiates right there at the impedance transformer and works very well also. It's safe, it's low voltage, and it's current fed matching rather than voltage matching. Now, one of the disadvantages is the counterpoise radiates. Well, they radiate for all the antennas that we have. That's a real good characteristic. You got coax, why not use part of it for the antenna? All right. So let's take a look at the SWR of these antennas. All right. Remember, 55 feet of wire now, not 66. So we have 11 feet less, and we're going to put a a choke on the coax 11 feet down from the impedance transformer. So the total antenna is that 11 feet on the coax plus the 55 feet equals 66, all right? But now look at the SWRs. Everything is virtually under 2-to-1, all right, for all bands. We even get 30 meters. 30 is a little bit above 2, but all bands are essentially below 2-to-1 and typically 1.5-to-1. So you don't need you really don't need a tuner for the POTA bands or most of the bands except for 30 meters perhaps, and maybe on 17 meters. That's about it. All the other bands are fine. And so it's a very useful antenna. More bands, shorter wire, safer, and it's more convenient because you're using part of the coax. Now, if we were to compare the 71 footer that we have with the 40 meter one that we just talked about, I compared the two SWR graphs, and the thing is that you'll find that for just about all the bands, one is better on some bands, particular bands, and one is better on other bands. But the non-resident one with the 9-to-1 transformer gives you 80 meters, and you can't get 80 meters on the 55 footer, but you do get a better SWR on some bands than the 71 footer. So they're both very useful. And in fact, their SWRs are better than the end-fed half-wave. Either one of those antennas has better SWRs than the end-fed half-waves, and certainly better on the work bands and on 6 meters, which they don't have whatsoever. So I put together a little table to kind of compare all these. And so in a quick snapshot, you can see that the wire lengths are shorter for the end-fed off-center feds. They're a little bit longer for the non-resident ones. But the advantage is, of course, that you pick up an extra band. That's 80 meters on that particular one. And all the other off-center feds, or the end feds, the non-resident and the resident ones, pick up all the other bands. But the end fed halfway stumbles. It only gets 4 bands naturally without using a tuner. The other ones all basically get all the bands with no tuner, or at least the SWRs are all under 2-to-1 for all intents and purposes. So a real advantage, more bands and less wire. In words, half wavelength is a good length that just has to be managed correctly. And we think that the resident end fed, we call it the end fed off-center fed, because it utilizes the coax rather than an actual wire itself. It's probably one of the better antennas that's out there right now. Nobody's copied us so far in this, and because they can't make the balance, the balance and the ununs good enough to use with these types of antennas. We make really good, like I say, balance and ununs. We don't use the classic way to do it, which has been used for years and years. We use beads, just like the solid-state linear amplifiers use. Much less wire and much less labor, so we keep our costs and our prices down, and much bigger bandwidth. And for all those reasons, we really like the end fed to off-center fed. And we're trying to convince people that there's another one out there to try, and this is one of the better ones. So I'm going to spend a couple of minutes now just kind of going through some of the ways you put these things up, and then we can have a break point, or I can talk a few more minutes on some other things too. How do you determine the wire length? How do you match it to the cable? What are typical configurations and those types of things? And then I do want to spend a couple minutes on noise filters, because that's an important topic. The non-resident end feds typically are anywhere between 41 feet and 155, and but typically the most popular are 41 and 71. And with those lengths, you can match anything from 40 through 6 or 80 through 6. Very convenient. We sell them through HRO, and we still sell hundreds of them a month, because they're just a good antenna, and they listen very well. They hear very well too, and they transmit very well. The resonant ones, the resonant end feds, where you have let's say 55 feet of wire and a 12-foot counterpoise using the coax, again works all bands 40 through 6. The larger one, the 95 feet of wire and the 40 feet of counterpoise, works all bands 80 through 6. And for the small fryer, for the people who don't have a lot of room, 25 feet of wire and 7 feet of coax, you put the choke on that. And the chokes are all included with the antennas, by the way. You don't have to buy anything extra except the coax yourself. And they work very well. As I said before, and I'll just quickly go over this, you can mount these as upward slopers, downward slopers, L-shaped, U-shaped, straight up and vertical, or straight horizontal. And it doesn't really seem to make any difference in terms of the loading and the SWR factors. However, if you put the impedance transformer up high, the coax will be up high, and if it's radiating, you'll get a nice vertical takeoff angle for DX purposes. Some of your SWRs may vary a little bit from the things that graphs and things that I've given you, just because of the different geometry of the antennas and whether you feed it at the top or the bottom, those types of things. But in general, keep it a couple feet away from metal objects. You can run it on a metal tower, just put it 2 or 3 feet away on a standoff at the top or something like that. You can run the wires through trees. You can put 90-degree bends in them. I think I have a couple of these on site, and I go out about 50 feet, and then I do a 90-degree turn, because that's where the next tree is, and I still can work everybody. I can work 100 countries in a weekend with some of these antennas on FT8, for example. Matching the coax to the antenna, we find that We like to use like I say, the 9-to-1s on the non-resonant ones, and the 4-to-1s on either of the off-center fed, the real off-center feds with 2 wires, or on the end-fed off-center feds. And if you pick the right point, you get lots and lots of bands, which is what we do. And by the way, our PEP ratings are much higher than most everybody else's. And the reason is because we make them completely different, so that in a small package, we can have more power dissipation than others do who make them the classic ways, because they use big rings with lots and lots of windings on them. We don't have to do that. I'll give you an example. Our 4-to-1 ununs, which we use in this end-fed off-center fed, only use about 12 inches of wire. That's it. Whereas a classical one is going to use three sets of wire, roughly 60 inches long each. That's 180 inches of wire compared to our roughly 12 inches. And ours are much, much better in performance as well as bandwidth. So we've been doing that for years, and it certainly pays off, because the efficiency is virtually 100%, about 99.5%. And that means you hear better and you transmit better. And as long as you're transmitting into a good load, people are going to hear you, and vice versa. Typical ununs and baluns, these are all ununs. You connect to an unun at the top with a eye bolt. It's also a halyard hoist if you want to hoist it up to a tree, for example, or a mast. And it's also the output. All right, we don't have extra terminals and all that type of stuff on here. And then on the side, we generally have an optional counterpoise. Okay, and I should mention just a few things about that. If you don't have a long length of coax, all right, the antenna still wants to see a counterpoise equal to a certain length. So for example, on our 71-foot antennas, it still wants to see a 42-foot long counterpoise. So you can put a choke on your coax at 42 feet, or you can put a wire off the side here at 42 feet, all right? The antenna doesn't care. The SWR, of course, will care, but you have to have one on there. So you don't ground it, the side terminals. You put a counterpoise on there. And we have all different sizes, from 100 watts to 5 kilowatts. And they are accurate. If you're a Ridicon tester and you're running 1,500 watts or more, you get our 5 kW one, and it will take a duty cycle of 100%, 2 kW, and no problem with our TTY or FT8, for example. Our TTY has about a 90% duty cycle. FT8's a little bit less than 50%. So even our 500 watters, I run 600 or 700 watts of FT8 through them, and they work just fine. We have different types of feed line chokes. Typically, if you're using the small coax, RG8X or RG400 for high power, you can buy a simple toroid ring. They're $10. But most of the time we use snap-ons. And the reason we do that is so it's very easy to move the position of the snap-on. So if you're running one of our 40-meter end-fed off-center feds, normally you would put the snap-on roughly at 11 to 12 feet. But in your case, because of the geometry, it may tune better if it's at 10 feet. And it's real easy just to unsnap the ferrite and rewind it a foot lower, and it works just fine. So anyway, we sell the complete antennas, and they're available as individual parts. All the manuals are online on our website, by the way. And by the way, this talk is also on our website and under speaker presentations. And we have all those parts available. You can, like I say, supply your own particular parts or use some of ours at the same time. Okay, I want to spend a couple of minutes here on noise issues, because anytime you're using end-feds antennas or wire antennas, or you're living in a neighborhood, you have antenna noise issues. And so we came up with a product called a coax noise filter, right around 2013 or 14, right after we got the company. And nobody's really copied that or picked up that idea, although it's fairly simple. So in a typical radio installation, you're going to have any one of these antennas. It doesn't make any difference. Or it can be a beam antenna, all right? The problem is always the same, all right? And here's the concept. I'm going to tell you the concept in words. Anytime you have a coax-fed antenna, you have two problems. And the reason you have two problems is because coax has how many conductors? It's got 3 conductors. If you remember a phenomenon called skin effect, all right, you'll understand what I'm saying. I'll say it in words for those who don't. If you put a signal up the center of the coax, it goes up the center conductor, but it also goes on the inside part of the braid. The outside part of the braid is a separate electrical conductor. So the reason that you put a choke on any coax-fed antenna, no matter whether it's a beam or a dipole or one of our off-center feds or whatever, is because that signal, once it gets to the antenna, the part that's on the inside of the braid, it says, okay, do I go to the other side of the dipole or do I go back down the outside of the coax? There's a fork in the road for that electron, you see? And so if you don't put a stop sign there called a choke, all right, if you don't put a stop sign there, it will go back down the outside. So and it will become part of the antenna. And guess what? If you don't put a choke there, the antenna length will be part of the antenna. And as you change the coax length, your SWRs will all change because it's part of the antenna. So what you should do for all coax-fed antennas is put a choke there. And there are different types of chokes and different sizes and all that, but you need a choke. Now, if you think about it, theoretically, all the way from that antenna feed point, all the way back to your radio, all right, choke or no choke at the antenna feed point, you have a second receive antenna. It's the outside of the coax, all right? So when you screw in your coax connector, you are hooking up 2 antennas. The antenna that's being picked up by the outside, the signal rather, by the outside of the coax, plus the signal that's coming down the center and the inside of the braid, all right? So so we created a coax noise filter to solve that problem. So here's a real simple test. And you can do this whether you have a noise filter or whatever type of antenna you have, all right? So here's the test. Turn on your radio, go to your favorite band, whatever band you want, and the first thing I want you to do is unplug the coax completely and see if you have a noise level. It could be coming in through a computer interface, it could be coming in through a switching power supply or something else. In other words, there's another wire hooked to your radio that's picking up noise if you still have noise. Your S meter should be pretty down to 0 if you're okay. All right, if you're not, fix that problem first before you fix the problem I'm going to tell you about right now. All right, so the next test I want you to do is I want you to take your coax connector and roll back the outside portion of it and just put in the center pin into the coax connector. Don't let the outside connect at all, and measure the noise level on and do this on different bands because it'll have different effects on different bands. And measure the noise level. Let's hypothetically say it's S1, all right, with just the center conductor in. These days it's probably about S3, S4 because of the noise. Let's just say it's S1. Now here's what I want you to do. Now I want you to screw in the outside and see if it jumps up. Because now you're hooking your second receive antenna. And if you're which is the outside of the coax, and if that coax is running through the attic or it's near the house, it's almost guaranteed you're picking up house noise on that. And if your S meter reading goes from, let's say, S4 to S6 or S7, it really jumps up, then I've got a solution for you. It's called the coax noise filter. And the coax noise filter will get rid of that difference. It won't get rid of the bass noise because that's where your signal is that you really want to hear. But it will get rid of, or it will suppress the noise on the outside, depending upon which filter you got, all right? So I'm going to give you some options here, and I'll show you how to pick one of these if you're looking for one. Typically, our little coax noise filter, and there's a picture of one. It's a little box about 3 inches long and about an inch and a half wide and about an inch and a half deep. All right, with two SO239 UHF connectors on it. If you plug that in right next to where your coax comes into your shack, all right, and that little one's good for 500 watts. We make them up to 5 kW, but that little one's good for 500 watts. What you'll find is that particular one will suppress up to about 38 dB. We're saying it, in other words, right around 6 S units of that noise that you got by screwing in the outside part of the connector. All right, so guess what? Now you can hear some of the DX or some of the signals that you couldn't even hear before by putting this little filter in there. All right, we sell hundreds of these a month to solve that problem. And it doesn't make any difference what type of antenna you have. All right, if you buy some of the bigger ones that we have, the 5 kW and the 1500 watt ones, all right, they're up to about 49 dB. We're saying in a different way, almost between 7 and 8 S units will be reduced from the outside if you've got a real major problem. And typically you'll have the problem on 80 and 40 and 160. That's where it really comes into effect. All right. So when you're buying chokes in general, at either end of the coax, for example, what you want to do is make sure you always look at the specs. I've looked at MFJ, I've looked at all the different manufacturers, and very few of them give you specs on, usually they'll give you the frequency range, but they won't tell you what they do within that range. All right, it's kind of like buying a resistor that, yeah, it's 150 ohms, but I don't know the wattage of it. I don't know what the frequency range is, and I don't even know it's going to do me any good. I just know it's got the right color code on it. All right, same thing here. Don't buy chokes without specs. All right. One more thing, and then I'm going to turn it back, and then we can take it from there. And that is antenna coax switches. All right, everybody uses those. And there's a problem with them that you probably don't even know about, but you're going to know about in about 5 minutes here, or a couple of minutes. All right. First thing is where do you put coax noise filters? All right. Usually you put them as the first item that's coming into your shack. So if you have an antenna, you have a long length of coax, you're going to plug it into a coax noise filter or a what we call a maxi choker for the high power ones. And then that goes into your antenna switch, which goes into your antenna tuner, a linear amplifier, et cetera, et cetera, et cetera. It has to be the first thing before anything that's in the shack. Otherwise, once you hook it to a switch or an antenna tuner, guess what? It goes to your ground system. The common mode current, which is the noise, gets into everything. You can't get rid of it. So what do you have to do? What you have to do is you have to put the coax noise filters ahead of the switch. And why is that? All right, you got to put it on the antenna side of the switch. And I have two pictures here. One is a simple two antenna switch, and the other one is a part of my flex radio system. This is 8 different antennas, and I have 8 3,000 watt maxi chokers on it. Okay. So, and why do you have to do these things? The reason that you have to do it is because antenna switches, unless you buy certain really good ones, expensive ones, only switch the center conductors. They're not switching the braids. So all the braids are tied together. So here's an example. You've got 4 antennas, 3 antennas, pick a number. And you're selecting antenna number 1. But there's all kinds of noise coming in on the braid on antenna number 4. And you are now hearing that noise because all the braids are hooked together, unless you isolate them with a noise filter or a choke. All right. Otherwise, you're going to have all that noise come. Doesn't do any good to have it does somewhat good to have it in the common line. The problem is the common line then has to aggregate all of the noises from all of the antennas together. All right. So it's much better to do it prior to the antenna switch. Okay. That's where I'm going to stop right now because we've been running along a long time now, but that's the idea between antenna switches and coax noise filters. If you're not using one, do the simple test, all right, on any antenna that you have and see if you need one. And if you do, you can go to our website and there's all kinds of information on them and different specs and all that type of stuff, as well as all of our other products. We do more SWR graphs and specs on everything than any other manufacturer that I know, and for a good reason. People really need that information to make a decision on a product that it's going to help out their shack. We want you to be happy. We want you to have good products. We want you to have them at a reasonable price, and we want them available for everybody who needs them. So I'm going to shut up right now, and I'll turn it back to you, Tom, and take it from there.
All right. Hey, great, Bob. Go ahead and turn your sharing off. There we go. We got your picture back on. Let me put your lower third in there so people will know who's been talking here. Well, that's Bob Brim, AK6R, and we've been talking about in-fed antennas. So, Bob, I got a question for you. I hadn't thought much about this, but since I've talked to you today and yesterday, I've thought more about it. Let me see if I can change pictures here a little bit. Let's see if that'll work. Okay, that'll work. Do you prefer the in-fed, what is it, the in-fed non-resonant versus the in-fed half-wave? Do you feel like that's a better antenna?
Yes, absolutely. Because the in-fed half-wave in our example was 66 feet. If you add 5 feet to it, I'll give you 2 extra bands. I'll give you 80 meters, whereas you couldn't get that with the other one at all.
Right.
Or saying it even a different way, if you use the in-fed, if you use the in-fed off-center fed, I'll subtract 11 feet from the antenna, and I will give you 11 bands, more than the 4 that you would have gotten on the other one. So,
yeah, I've never really done much with the in-feds. I've got like a 40-meter extended double zep and some delta loops and dipole. I've got all kinds of antennas. I do have a couple of halfway vertical antennas that I've played with. And first of all, I used the 450 ohm matching stub, to the quarter wave to match it. And, I came in and turned the little alpha amp on, and everything was looking really good match. And I went outside, and the feed line was on fire. Not the feed line, but the matching line, it was dripping. The plastic little balls of fire were dripping. There's really a lot of voltage on that. I ended up making maybe a ladder line with just, 2 number 12 wires and some 6-inch spacers, and that seemed to hold it pretty good. I seem to see a lot of places use a formula for like a counterpoise like 0.05 of the wavelength. Does that play in anywhere in your dimensions?
Yeah, well, that's the in-fed half-wave.
Okay.
Right, because theoretically, you're using your voltage feeding it, and so theoretically, I mean, every antenna is a dipole, whether you like it or not.
Yeah.
There's got to be a positive and a minus, no matter where you feed it. So what they say is, well, your counterpoise is only 16 inches or 18 inches. It's 0.05 wavelength, okay? And in fact, most people just they don't put a choke there, so they're just using the coax as the counterpoise.
Yeah.
Right.
And it's too long. Yeah.
It's too long. And guess what? All that radiations also go right back to the radio, right? And so that's one reason our in-fed halfways, when we did sell them, had chokes on them. We wanted to stop that. And,
so the resonant.
Incidentally,
Go ahead.
No, incidentally, if you do take it from more than 0.05, a secret is you can get some of the work bands.
If you take it more than that, okay.
Yes, you do. You can take your 66 feet and you take that thing down about 16 feet. Now the work bands start to show up. All right.
Yeah.
But the transformer will still be working like a son of a gun because
non-resonant versus resonant. Let's talk about the resonant half wave. Does it create a problem with the 40 meter and the 15 meter? You know, 7 megs versus 21. The alignment of them, does that cause an issue in the half wave where you don't have that issue in the non-resonant length?
Well, the non-resonant length is not resonant in any of the hand
Yeah,
bands.
right.
So what you're doing is you're trying to pick a feed point along the antenna where everybody's happy but nobody's optimum. Right? Or saying in a different way, you can work as many bands as you can, and the SWRs are typically under 3-to-1, mostly under 2-to-1. All right, so that everybody gets a chance to eat at the table. Right? If you on the end-fed half waves, you only got 4 choices. That's it on the ones that I was giving an example. You get 40, 20, 15, and 10. Now, when you make these antennas, either end-fed half waves or the end-fed offset or feds, the resonant ones, you have to cut them for the low end of the longest band. So you got to cut it for 7.0 in order that you get 14 and 21 and 28. If you cut it for 7.2, you're 14.4, and the second one you're out of the band.
Right.
So depending upon how friendly your radio is, all right, and you want to work sideband on 40 meters, but it's cut for 7.0, you may have to tweak your antenna tuner a little bit. But the balun will be okay. The unknown will be okay because it's such a small difference, all right. But if you try to use it on 30 meters, it would just go bazong. Yeah.
Well,
Because
you know,
it
and
just-
you mentioned like the I guess the ZAP antenna with the feed line match and so forth.
Yep.
I discussed that a minute ago, but that only gives you one band. And of course, now with the new the unums and stuff, I guess they're so broadbanded now. You can spread that across all the bands.
Well, the ones we make that you
Yeah.
do.
Yeah.
I like your national receiver, Brett, by the way.
That's a big receiver he's got there.
Oh yeah, it's a beautiful one.
It takes up
Yeah.
a whole tabletop.
Here's my vintage shirt.
Oh, okay. All right.
I'll vacuum too.
Yeah.
Yeah.
So what do you got there? What do you got there, Brett? What do you got?
Oh, well, here is a non-resident, something I improvised just recently, and it's actually turned out to be a better antenna than I expected. This is an example of a non-resonant dipole. I used a 9-to-1 balun, 84 feet of wire off the end, and then
Yep,
I
that's
tried
good.
it both ways with a 17-foot counterpoise that was wire. And then I discovered that you could just choke the coax at 17 feet and just make the coax into part of the counterpoise. That got me all the way from 80 up to 6 meters with reasonable SWR. So I found that worked very well. And, I've improvised exactly the sort of things that you're talking about. And yeah, if you get the lengths right and, you've got an antenna analyzer and you can see how well you're doing, you can do a lot of this. And it's, this sort of antenna works very well. The one thing I have not tried that I've seen, and I saw one of these at Field Day, I want to try it, is I'm very curious about what would happen if I made a trapped end fed. So that I could maybe get things like the work bands by having a trap there to get the unusual length that you need. That isn't just a harmonic of one of the others. I don't know. I don't know if that would work. I did encounter someone at Field Day who was using one and seemed to be getting good results. But of course, Field Day you don't use the work bands, so he just described it to me. I didn't have a chance to actually test it.
Yeah, you can use a loading coil too to make it seem longer on certain bands, rather than a trap. I don't like.
Yeah, there have been we've had some comments in the chat room here where people saying that the non-resonant end-fed is their best antenna.
Yep.
So I may experiment and play around with some there. Well, Bob, hey, let's do this because it's 9:15. This is a great discussion. I mean, I'd like to carry it even further if you have time, Bob. But can we first give away a prize here real quick? Do you mind waiting, Bob, while we do this?
Oh, I'm good. I'm good.
All right, so let's just take a break here real quick, guys. And what we're going to do is we're going to give away a Bob Heil ham radio handbook here. And this is one, Bob gave me several. He had autographed them. You can see in here. Bob says here, keep it all in phase. So that's one of Bob's saying, keep it in phase here. So we're going to give this to some lucky person right here. So let's get Hambot cracked up here, and we're going to give away a prize real quick. Guys, if you've never used Hambot before, listen, here's what we're going to do. Hambot is going to pick a name in the chat room. He's going to call your name. All you have to do is just say, I'm here, hit a period, hit a character, do something, just let us know you're there. Because Hambot's going to count down the time, and if he doesn't see you, Hambot is going to call another name. So just try to refrain from chatting in the chat room while Hambot is working. And we're going to get going here with Hambot. Let's see, where's Hambot? Come on in here, Hambot. Where's Hambot? Okay.
Looks like it's KC5SLQ.
Yeah, that's who we're looking for. Did he win? Okay. Wait a minute. Did he? No.
Yes, he did.
He did?
Yes, he
Okay.
did.
It's so fast I couldn't even see it. All right, so
Yeah, I'm
KC5SLQ won, and we will get this in the mail to you maybe by tomorrow, and it's a nice handbook, and a lot of this stuff is stuff that Bob practiced himself. You'll see some of his own antennas in here. You'll see some radio theory in here, electronic theory. He's got tips on how to do a lot of things, all kinds of stuff. So it's interesting whether you're a young ham or an old ham. There's a lot of stuff in here, something in here for everybody, and I think you'll enjoy it. And we'll send this out to you tomorrow. Thank you so much. Boy, that was fast. Congratulations.
Yeah. I
Congratulations.
got very lucky at the Huntsville Hamfest just before Bob passed. I bought that book and got him to sign it for me.
Yeah, it's a good
Wonderful
book.
guy.
I've read through it from front to back. It's a great book. All right. Well, hey, man, I have learned so much tonight about, there's a lot to these in-fed antennas that I didn't know about that Bob has explained tonight. It opens up new possibilities here, really.
Well, he's actually answered some long-standing questions I've had with my stations through the years, which was 15 meters always seemed to be a very difficult band for my rigs to tune without SWR issues and RF back on the coax and everything. And you pretty much answered it with the skin effect and the two antenna pieces. And I've noticed that coax length had always been an issue with me on 15 meters. So yeah, I know what I'm buying in Orlando.
You gonna buy you an antenna?
I'm probably gonna buy the end fed, off center fed, and at least one or two of the noise filters.
Well, that's cool. All right. Hey, and that's coming up
yeah.
here soon, guys. The Hamcation's coming up February 7th to the 9th. We're not going this year, but
I am.
there's the man. He's going. You'll get to meet Glenn down there.
I just got
we'll be at
confirmation
the,
today that I will. Oh, go ahead.
No, we'll be at the Yuma Hamfest. That'll be our next one we're doing.
Yeah, the
Oh,
one
okay.
after.
And
But,
maybe
yeah,
Quartzsite too. Yeah.
I'll be doing an Arduino forum in Orlando on Friday afternoon. So y'all stop by and say hi.
Well, Bob, it's been fun. We learned a lot tonight,
Absolutely.
and I'm glad there's some other old hams out there like me. Bob, one of the things I read, and people maybe they don't believe this, and I've told them this before. They probably don't believe it, but you did it too. We both held the novice and the tech license at the same time. And that was kind of cool. You know, I worked the novice bands on CW, and boy, back in the 60s, early 60s, the 6 meters was pretty hot, and 6 meter AM. And that was a lot of fun to be able to get on some voice while you were a novice. So that was really interesting there.
Yeah, I made one of those 6360 6 meter AM rigs that was in the handbook at the time.
Oh yeah.
That and my Heathkit tour, it got a lot of use. It was very,
Well,
very
you know,
nice.
And I sent you a picture of that T150. If you remember, that T150 had 6 meters on it, so it was just a
Oh yeah.
it was a perfect rig. I got to use the VFO on 6 meters, but I had to be crystal control on 80 and 40 and 15.
Yeah, I have a T150. That T150 and R100 are in my shack.
Oh really? I saw the picture you sent me. Man, I feel kind of. Yeah, I saw the picture. I feel kind of funny inside every time I see it. You know, oh man, you know it's why did I ever get rid of mine? You know, wow. But it was a good radio, and I built a number of transmitters. 807, 1625, 6146s.
Oh, yeah.
Transmitters were easy to build. The receivers weren't that easy to build.
No.
But we had
Got a
fun.
commercial. Yeah.
We had
Got a
fun back
commercial
in.
ticket, too.
Yeah. We both have the commercial tickets there. I've got the well, it used to be the first class. It's now called General Radio Telephone.
Yep.
I've got the ship radar endorsement on it, but I've never really worked on a ship radar, so I don't know, man. I don't know. Anyway.
That's how I got through college. My first 2 years with that license, fixing up two-way radios and stuff, and then I learned how to program Fortran. And
Oh,
the
really?
pay
All
was
right.
Oh, Lord.
4 times as much. Yeah, I went to UC Berkeley.
Yes.
And good school.
Punch cards.
Yeah, it was all punch cards. Yep, and teletype 33s and all that kind of stuff. And so I ran a 28 ASR in my shack, a teletype with the type box and stuff on it, and became a real good RTTY contester back then.
Well,
But
Bob, I went in the Air Force the last century, and they sent me, I think I spent 9 months in teletype repair school.
oh my gosh.
So, you need to pull the main shaft out of that Model 28. I could pull the main shaft of that Model 28 out.
You're never going to play the piano again.
But you know what? I never had to do that. In fact, my whole 4 years, I don't know that I ever repaired a teletype. My whole 4 years, they never broke,
No, those were solid machines.
Yeah, they never broke. Oh, man. All right.
Well, it's funny you talked about the commercial licenses. My first license was the 3rd class with the broadcast endorsement, and that's what got me my first job at a radio station at age 16.
Yeah.
So, yep.
We all started similar.
My experience with teletypes was using BASIC on an old IBM mainframe, and then having wars with the other students with the Chads.
Yes.
Yep.
We would dump the boxes of Chads on one another.
Oh, gosh, yes. I worked in a place and we had 5 key punch machines and a couple card punches, and I mean, we generated buckets of Chads a day, and they were all put to good use.
Yeah.
You did not open a door without kicking it open or whatever. I mean, we must have dumped a 3-foot square box of Chads on somebody when they forgot and opened the door. And I mean, it darn near knocked them to the ground. It was that many
Well,
Chads.
that is not fun. That stuff's hard to clean up. You should be ashamed of yourself, man.
No regrets.
Yeah. Oh boy. Okay. Well, hey, Bob. Of course, our show is always recorded. It's on YouTube forever. So people can, if they want to go back and look at parts of this, they can see us on our YouTube channel, or they can go to Palomar Engineer dot com.
Palomar-engineers.com, and under technical information, it'll say speaker presentation. So all the presentations I've done for the last 10 years is up there, and you can look at the one for W5KUB too.
All right, very good. So there will be a lot of people that still see this probably over the next days, weeks, and months. So man, we really appreciate you coming tonight. It's about 9:30. It's about time for us to close our show for at least our shortwave. We really appreciate you being with us tonight, man. I think we learned a lot.
Sure did.
Good.
And you're welcome to come back. You're welcome to come back and visit with us anytime.
Yeah, we do one on RFI too. That's another talk I do.
We'll do one. We'll do one on RFI at some point when you have time.
Yep, that's good. And in fact, this talk has got about 10 slides on that, but I decided to stop it at the Hamfests. So it's on the website, and you can look at that also.
Okay. Well, very good.
Pleasure,
well,
Peter.
Thank you, man, so much.
Thank you.
We'll see you. All right, Glenn and Brett. Anything else we want to talk about before we close, man? We've got,
I got two things.
All right. What do you got?
Well, one thing you neglected to mention.
What?
We had a boatload of snow here in Arkansas.
Oh man, did
last
we?
week.
Yeah.
I got 10 inches on my back deck.
Yeah.
There's still snow on the ground out here. It's one of the biggest snowstorms I've seen in the South.
I saw Little Rock was saying 11. You're up at Conway, so you're nearby.
I'm in Conway, so we were right at 10.
We had 7.5 here at the airport.
Yeah.
That's the big snow for this area here. And Bob
And one
here,
more thing.
I don't know if are you still there, Bob? I think he may have dropped
Looks
off.
like he disconnected. He
Yeah, he
waved and disconnected.
So yeah, when we get a 1/4 inch of snow here, boy, that's pretty serious.
Yeah, 9 inch. The town was shut down for 2-3 days. Fortunately, it was a weekend. My power didn't blink. We're all fine. And I got one more thing, and that's in line with all the snow and the cold. In 2 weeks, on the weekend of the 27th and 28th, is Winter Field Day.
Yeah.
And a lot of clubs are participating in that. I know that the Conway Club is gearing up for Winter Field Day, so I'll probably get out and operate some there. But if you're into contesting, Winter Field Day is kind of a fun one.
Yeah, I'm not sure if I'll get out anywhere too. I might. I don't know. I usually come down and see. I usually come down and see you guys down in Mississippi, but you're not there anymore. So
I'm not there, but they'll be there. I'm sure they're going to be there.
Yeah.
I don't think they're doing it at the park though. They're doing it somewhere else this year.
All right, let me do one more thing here, guys, before we go. We'll be right back. I'll be back in a minute. Whether you're connecting with friends near or far, tuning into the joy of the airwaves, or exploring new frequencies under the sparkling winter sky, Icom has a perfect radio to keep you in touch with what matters most. The ID58 provides hours of fun and enjoyment working with your favorite bands. Beginners will love the easy D-Star settings, scope and waterfall display, voice messaging, and share picture function. It also uses the same optional accessories as the ID52, the ID51, and the ID31. For more information on Icom radios, go to www.icomamerica.com/amateur. All right, guys, we are back, and we've got 1 minute left officially. Anything else, Brett? What do you got, Brett?
Well, let's see. The event I'm going to this weekend is we're talking about. The Northern Colorado Amateur Radio Club is having the first big Hamfest of the year. It is midway between Fort Collins and Loveland, Colorado, along I-25 at this big convention center they call the Ranch. And I go there every year because it has one of the best flea markets in the country, and certainly in the area. And so I recommend it. If you look it up, if you type in NCARC into your browser. That's their abbreviation. You'll get the information for it, or go through the ARRL site through the list of Hamfests. But I will be there, and I do recommend it.
NCARC, guys, check it out. Well, I wish there were more Hamfest around closer to me here. I'm missing Hamfest.
Funny you should mention that, Tom.
Yeah, what do we got?
Hoxie, Arkansas, February 14th and 15th, and that's over near Jonesboro area.
Is
So
that the
that's
one north?
drivable for you.
That's north of Jonesboro, isn't it? Is that
Yeah.
the Crowley's Ridge or
No, that's separate.
Hoxie?
Crowley's Ridge is on April 19th, but Hoxie, Arkansas on February 14th and 15th. It's going to be a 2-day one.
February 14th and 15th. I might try to go up there. Now, is that
Yeah, I'm
further
gonna
for
try to
me?
make it.
Is the Hoxie one? No, wait, not Hoxie.
Yeah.
Is the other one further away? Is Hoxie closer to me than the?
Let me look it up here.
Yeah. Fort Worth is this weekend.
It's over
Fort
near
Worth,
Ridge.
that's Friday and Saturday. It's where?
It's over near Walnut Ridge,
Yeah.
and from Collierville, Tennessee. It's 121 miles, right at a 2-hour.
Okay.
It's
120 miles.
It's northwest of. It looks like it's about 30 miles, 20 miles. It's probably 20 miles northwest of Jonesboro.
Okay. All right. So if anybody in the chat room is associated with the Hoxie, Arkansas Hamfest, February 14th and 15th, give me a shout. Give me more information about it. I may try to get up there. And Glenn, if you get up there, I'll see you there, man.
Oh, I'll be going. Here, I'll send you the link for
I
it.
think April. Memphis Hamfest is in April, I think. If I'm not mistaken, it's April. I don't know.
Yeah, I'm about to email you a link about it.
Okay. So that's coming up. April. All right, well, there's a few. And then, of course, in March. Yeah, I think March the 9th is the Russellville Hamfest. I'm sure Glenn will go to that because, Glenn, you're
Absolutely.
only 50 miles from that one probably.
That
or
is
less.
correct,
I
yes.
mean, from Conway, Arkansas over to Russellville, Arkansas. So I'll go over there to that one again this year. All right.
Okay, here we go. It's the LCRC Winterfest. I'm going to send you the link off of ARRL's page.
Okay. I'll check them out. I might want something to do February 14th. Maybe just drive up there. It's only 120 miles. I should be able to get up there in about 45 minutes.
Yeah,
Yeah.
but I'm definitely going to go because it's close for me too.
All right, guys, I'm going to say 73 is everybody. Good night. It's popcorn time, and we will see you next week. If anybody has ideas for topics or segments, please contact us. It's tough trying to find something every week to have on here. I think we had a good show tonight. Come on in here if you got, hey, do a show and tell if you built something, or if you hey, let's talk POTA, let's talk soda, let's talk MOTA. Is there a MOTA? POTA, soda, TOTA? I don't know.
No, I don't think so. Not yet.
All right. Oh boy, James is having popcorn popped in bacon fat. Oh, and that probably pretty good there. Yeah.
Probably pretty good right up until the point that your arteries clog shut.
Yeah. Well, yeah. I'm a little worried about that in my sausage and biscuits too. But I always sop all the grease out with a napkin. Before I eat. So I think I just invented the MOTA. That's I don't know. I have to come up with a name for that. All right, guys. Good night to everybody. We don't have anything else here. We're just burning time here and keeping me away from my popcorn. I think we had a good show tonight. If you missed any of it, you can go back. We're on YouTube. You can rerun it and check it. And if you missed something or you need some clarification, it's out there. 73 is good night. We'll see you later. Thanks a lot for everybody joining us tonight, and we will see you next week. And hey guys, the new system seemed to work okay. I didn't have a lot of trouble finding the right buttons here, and I'm kind of learning a little bit about the different parts of it.
It even worked first time for me.
Yeah, well, I mean, I can even do this. Look, man, I can bring Glenn in like it full screen, and watch this. I can even, let me think about this. Oh, I can even put Glenn's lower, oh, watch it, look at here. I can put Glenn's lower third on here. How you like that, boy? That looks sharp, man.
Yep,
I can
and by the next show, those walls behind me will be all fixed up and finished.
All right, and I can even make a mistake. Watch this. I can even make a mistake. Look at that.
Oh my gosh, I just lost weight.
Did you?
Sure.
All right.
Yeah, my
okay.
IQ just doubled and I lost weight.
Hey man, hey, that wall looks good behind you back here. It looks nice and clean, and
Yeah,
it
it's
looks
painted.
good.
I'm getting ready to bring in the furniture and stuff. So we're
Oh
getting
man,
there.
looks good. Looks good. Okay. All right. We'll see you guys next week.
All right, man. Have a good one.
Good night, everybody. Good
Stay
night.
warm.
All right. Good night, everybody. Good night.
You're the man! I've been looking for this for weeks.
That didn't work right.
So you're saying I can ask this cat any question?
The cat is connected to the computer. You just type in the question, it will read his mind. There the answer comes.
You're the man! I've been looking for this for weeks.
All right. Good night, everybody. We'll see you.
Good night. Have a good one.
Good night.
Take care. Have a great week.
Trying to figure out how to turn this thing off. Here we go.